Hi there, this is EFQuest. I have a little exciter circuit here, and and the reason that I put it on YouTube is because I believe it's quite interesting to see. I'm working mostly with Joule thieves and sec exciters, not for a very long time, by the way, but I found some very interesting circuit when I was experimenting with Joule thieves in combination with exciter circuits, and after some adjustments with the Joule thief, I found out that if I put a toroid coil with a single wire across the plus and the collector of a transistor, I could light up LEDs with almost no amp draw. So I'll show you what I mean. It's a little hard to understand like this, but anyway, I have here my power supply. It's 12.4 volts at the moment. I have here some LED cups. These two are from Nichia. These are not meant to light up. They are just having some filter function in this circuit. And I have here two Loxian K LED type of cups, and these are 14 watt each. And I'll have here the adjustable pot where I can change the gain to the base of the transistors. These transistors are by the way, oh, I just have to, now it jumps, you see. I'll put the light off here. That's I don't know if it's if you can see this, but the LEDs are lighting up quite bright, and I don't know if that's maybe better. I have them mounted on a metal plate. And see, that's a lot of light. I'll just put them like this, and the amp draw is about 0. Not really 0, of course. It's just so little that I can't measure it at the moment. If I can put the voltage up on here, and if I do that, and you see the light is getting much brighter, the amp draw goes up, but I can just put it down again with the pot to 0 again, and the brightness of the LEDs stay the same, and I can go up to more and more and more, and still I have almost 0 amp draw. It's very sensitive. Even if I touch the metal plate where the LEDs are mounted on, the amp draw goes crazy. So let's see. Oh, I get some plasma also here. I just put it a little higher. I put the voltage higher, and the amp draw goes down, and the LEDs are going brighter. So that's a really interesting thing, and the interesting thing about it is these LEDs, which are not lighting at the moment. What's happening here is these LEDs have a strange effect on this whole system, because if I, let's say, put it on 15 volt and the amp draw is 0 again, if I disconnect, oh, let's make a little light here. If I disconnect this one, the amp draw goes up to 100 milliamps. I connect it back and the amp draw goes to 0 again. The light remains the same all the time. This LED is from the plus goes to the minus of the power supply. The minus goes to the plus. So for somehow it's feeding back some power into the system, and the same goes for this one. This one is across the two wires of this toroid coil, and that's the same effect. If I disconnect that one, that will the power, the amp draw will go up also. So this tower is 30 centimeters long, about 5 centimeters in diameter, and it's made of toilet paper rolls. Something interesting is this is just a loose hanging crock lead. It's not connected to anything, it's just clipped on the paper there, if you can see that. If I touch this one, you see the amp draw go up immediately. If I let it hang, the amp draw goes to 0. So basically I really don't understand what's happening here. I'll show you the schematic. This is the schematic of this all. This is my first revision. I call this circuit the F-Citer, and this is revision 1, and that's with a single transistor. The transistors here are connected in parallel, and I did that just because this transistor gets very hot, and I was thinking, like, if I put another one in parallel, maybe they share the load, and that's also what's happening. But it also brought some extra effects. It enables me to easier justify the whole circuit. So it's less difficult, it's less sensitive, because like if I put my hand near the coil, the amp draw goes crazy. I think you can see that. It's very sensitive. It does all the wireless stuff, of course. Like this one is very bright. And if I put it on some metal further in the room, it also lights. It's really crazy. Again, this is about 1.5. This is about 40 centimeters away from the coil. If I put it closer and closer, you see the amp draw goes up also. Oh, not in this case. Now it goes. With the double transistor, I also get some plasma. Not right now, because the voltage has to be a little bit higher. And okay, what else? Now the schematic again. This one was the first revision, as I mentioned. The adjustments, it was so sensitive that it was very hard to get it on the 0 amp. It's of course not 0, but it's less than 10 milliamps. The light is at least, I don't know if you can see that from the camera, but I have to put it like this because I cannot look into it. I immediately have some black spots in my eyes, so it's very, very bright. At least a few watts of light is coming out of there, and I have no idea where it's coming from. The schematic, this is, okay, let's see how to, okay, like this. The components, hope you can read it. by the way, these Nichia LEDs are starting at 30 volts, so they are not burning, they are not lighting up below 30 volts. If I disconnect these LEDs, this one will start burning, and I can do the same with this one as with that one, but I found that this works a little more efficient. So the load, this one is this one, the D6 here, I don't know if you can read that, but it's D6. It's this one. I put back on the light, it's a little bit easier to see. This one is across the power supply, and that's really a huge difference in M-Draw. This LED is really doing all the work, or most of the work. The M-Draw goes back from 100 milliamps to 0 almost. This is the normal part from a SEC exciter, of course. This is a BD39 139. This too. This is the tower, primary, secondary coil. This is the loose hanging crock lead. If you can read that, I just pause the video, I guess. This is the toroid coil. It's about 19 winds of gauge 22 wire around it, and that's the variable pot there. So what's happening here, I really don't have a clue. So it's a normal exciter type of circuit with the toroid coil and the LEDs. The M-Draw goes to almost 0. And again, I can go up to about, let's say, you see it getting lighter and lighter right now. The strange thing is how the higher I put the voltage, the less M-Draw. I now have 21 volts. I have plasma here. I don't know if you can see that. Let's see. Probably you can. There it is. Oh, it's too much. And there it is. You have plasma. We have a 0 on the gauge, on the M-Draw. We have really a lot of light. Well, let's see if I can demonstrate that a little better. Put off the light here and put off the light here, and I can really light up the whole room with it. It's incredible. So much light. Really a lot. If I hold it, only if I hold the plate in my hands, it's an aluminium plate there, the M-Draw goes up. If I let it go, it goes back to 0. It's a very, very strange circuit. By the way, I measured the frequency with the multimeter and with my oscilloscope, and it's running on about 2.5 megahertz. So, and that's of course why you see this. Anyway, if anybody has an idea how this is working, I really would like to learn more about it, because I really can't get my mind around this. It's you see, it's still drawing 0, less than 10 milliamps. I get at least 4 or 5 watts of light, at least. And I have a LED burning there. The transistors get very hot. So that's also a lot of power. It's coming from somewhere, but I have no idea how it works and where the power is coming from. So if you have any idea, please let me know. Thank you very much for watching.